Yes, that's it. Yeah.
Yes, this one.
Yes. Oh, which part confused you?
It's just the graph itself. I don't know. The graph is confusing me and I don't know how to draw the graph.
You just don't know how to draw the graph, okay? So
Yes.
let's draw this. See what's going on here. So the first we have to know, do you know how to draw log? Give me a second. Let me, okay. Okay, first, do you know how to draw the log? The base 3, how to read it? So we read it. This is a base. This is a log. So read log base 3 of x. If you want to read it, just represent log base 3 of x, okay? But it's just a basic log base 3 of x, which depends on this 3. If this is the number here, we usually use b to represent. And this number is larger than, if this number larger than 3, so let's say this number larger than 3. If this b, if b larger than 1, this is the same as exponential. Remember exponential? Let's say b to the x. If b is larger than 1, so this is exponential increasing, okay? If it's a b, is between 0 and 1, so this is exponential decreasing, okay? So this is same as the log. If a b is larger than 1, so it's exponential increasing. Why exponential increasing? This is b to the x. So we will have the corresponding inverse. If I want to draw the inverse, the easier way, we draw a line. What's the line? Y equal to x. So the graph will reflect about this line. This is like, say, this we have exponential 0, comma 1. Sorry, guys. So we have then we have the exponential 1, comma 0. So if my function is increasing, so my inverse function also increasing. Sorry, guys, have to keep like doing this. So this is C here. What's your name? What's your name? You just asked me. Hello? Hello? Maybe you turn off your mic. So if you want to know this, this is, if this is like increasing for exponential b to the x, then this is the purple one is log base b of x. So right now we go back to there. So this is, what about log base 3x will be same shape as the purple. That's a purple. So this is a purple. So that's what last time I just draw this a black one. It's remind you this is a black one. It's represent log base 3 of x. Okay, that's increasing. So this is log b base b of x and the b larger than 1. Because the exponential b larger than 1, so it's increasing. So same thing, b larger than 1, so my log is still increasing, just increasing very slowly, but still increasing. So after I draw this by parent function, then we start to find asymptote issue. What's the asymptote? This is like, first we can figure out this is the left, this is like a move to left and move to right. If I have f of x plus c, this means shift to left c unit. So what about x plus 3, so means shift to left 3 units. So means f of x plus 3 means, this adjustment means shift to left 3 units. Shift to left 3 units also means my asymptote a shift. What's asymptote means? Asymptote means I have, this is my graph for log base 3 of x. So the black one, right now talking about the black one, the vertical asymptote is x equal to 0. What's x equal to 0 means? The y-axis. I have to shift to left 3 units. So my vertical asymptote become from 0, left 3, so 0 minus 3 equal to negative 3. So my vertical asymptote become x equal to negative 3. Is that okay for this part? It's okay?
Yes.
So, okay. So right now, my graph will be like this. Right? All the points to left 1, 2, 3. So this point here, 1, 2, 3, just roughly here. This represent this one. It's represent log base 3 of x plus 3. Okay? So right now, add a negative sign before that. What's add a negative sign before that mean? What's that mean? If any point add a negative sign, say this point, let's say this is anywhere, there's a point here. A positive, right? Is a positive y value. If I add a negative sign, means this a positive will become negative. So this add a negative sign means, roughly means if I have f of x versus negative sign before f of x, because f of x represent y value. If I add negative sign means reflect about x-axis. So when we're doing kind of like a translation, step 1, horizontal shift. Step 2, horizontal vertical stretch or shrink. Step 3, reflection. If I have negative before f of x, like this case here, before that, so reflect about x-axis. Reflect about x-axis means all the corresponding y value change sign. So that's why all the value here, reflection. Okay, just become a red one. This the red one will be the new graph. Okay, that's it. This is okay. So right now I need to find the intercept. How to find the intercept? Intercept just x-intercept or y-intercept. You can start from this. This is very clear. What about this point here? This is 0. This is 1, 0. Shift to left. 1 minus 3 equal to negative 2. So this is negative 2 comma 0. That's fine. Okay. So you have x-intercept negative 2 comma 0. What about y-intercept? How to find a y-intercept? So you just simply solve for f of 0. If this is a function, so we have f of 0 is equal to negative log base 3, 0 plus 3 equal to what? What's that equal to? Negative log base 3 of 3. What's this equal to? What about this equal to? If we have the very basic log definition one more time, if we have exponential, this exponential, this is a log base b of x. And we can compose like b. We can use b every time cx are replaced by log base b of x. So if we see have the same base, this exponential composed of a log, this can cancel equal to x. Same thing, we will have a log base b, x this time replaced by b to the x. So these two also cancel equal to x. So we notice that if we have log base b of b equal to 1. Another way we can prove it, we can simply use definition b raised power to 1 equal to b. So we have log base 3 of 3, this will equal to 1. So we just drop down negative sign, so equal to negative 1. So this become the y-intercept will be 0, negative 1. X-intercept is easy, just solve it. So we can simply solve it just a starting point from 1, 0, shift to left 3, 1, 2, 3. So become 1 minus 3 equal to negative 2. Another way, just simply solve it. How to find x-intercept? You can another way is set f of x equal to 0, but this way it's harder. The horizontal shifting will be easy. Just from here, 1, 0, shift to left, so 1 minus 3 equal to negative 2. So this is easy way, and this is harder. Why harder? You have to solve for. So we set f of x, which is negative log base 3 of x plus 3 equal to 0. Okay, this is okay, equal to 0. So how to solve that? We can simply both sides divided by negative. We just divided by negative 1. So this become log base 3. I don't suggest this way, but this is another option equal to 0. By the definition, so base raised power to 0 equal to everything. So this will be 0, 3 to the 0, the number to the 0 power equal to 1. So x equal to 1 minus 3 equal to negative 3. Okay, this is another way we can solve, but I will suggest just simply move from 1, 0, shift to left 3 units. So 1 minus 3 equal to negative 2. So this is easy way. I guess this will be in the final. Okay, I guess, especially the log function and exponential function will be in the final. Anything else?
Thank you.
And I don't know if you understand or not. It's just like, if you know, I can explain one more time.
No, I understand it better. Thank you.
Okay. What else? So maybe huh? What? Anything else?
Question 18 in exam A.
Okay. Question 18 is MA. This one? This one, right? Okay, let me touch base. Okay, let me do not use this one. I just want to start from beginning. Okay, just solve it. Let's erase everything. But first, I want to compare what's the difference between the exponential and the log. So I want to do one more time. Let's like today's the first time to teach, like treat as this. If we want to know e to the x and the ln x, what's the difference of these two? So this called exponential. And this called log. Okay. So the key is both are exponential increasing or logarithmic increasing. Why? Because this is a base number is larger than 1. This is also increasing because both log and exponential, we have increasing and a decreasing. Why this is increasing? This is called special log, called natural log, which is base E. So you just write a shorter version for ln x. So this e is larger than 1. So logarithm increasing. What's increasing? This is increasing. What's that increasing? That's increasing means, okay, that's called increasing. This increasing just very slowly, but still increasing. If increasing means, what's increasing means? Increasing means if I have ln 2 minus ln 1 must be positive. Or ln 3, ln 1, 0, nothing. Ln 3 minus ln 2 must be positive. Why positive? Because the function is increasing. So when the x value getting bigger, the corresponding ln 3 must be larger than ln 2. So increasing function ln 3 minus ln 2 must be positive. Sometimes I mention, what about, right now we're talking about something else. So what about domain for exponential function domain? For exponential function domain, negative infinity to positive infinity, of course, we have a range. So we have same for the inverse. This is inverse of exponential. So based on inverse function property, we just accelerate a little bit. E composed of ln x equal to x. Because exponential, because the function as inverse function, they undo each other equal to x. Remember, function compose inverse equal to x. And the inverse compose function equal to x. Since they are exponential and a ln function are inverse to each other, so this rule exists. What about another one? What about ln compose exponential also equal to x? Because ln function compose exponential function, they are inverse each other, so undo each other equal to x. So then we go back there. So what about domain? What about range? We notice that the domain and the range, how to find inverse, we just interchange x value and y value. So means if it's a domain, must be my range for inverse function. So domain become inverse the range, negative infinity to positive infinity. What about range for exponential? We notice that exponential, if it's increasing, we must be passing the point called 0, 1, which we have x-intercept. X-intercept 0, 1. Okay. Oh, sorry, this is y-intercept. Y-intercept 0, 1. Why? Only y-intercept, because we don't have x-intercept. Why we have no x-intercept? Because we have horizontal asymptote. What's the horizontal asymptote? Horizontal asymptote without shifting. If plus 1, that's different case. Without shifting, horizontal asymptote is x-axis. X-axis represent horizontal line, so we use a function y equal to 0 to represent. This still is a function. Y equal to 0, it's a function. So now we go back, so we can give a roughly graph. We can put 1, then e to the 1, around 2.71. So we used -1 here. What's a -1? So e to the -1, 1 over e, around 0.5 something. So we just connect them. This is e to the x function, increasing. Okay, so notice that this one, since we do not have x-intercept, so we have, this is line. What's the horizontal asymptote means? Horizontal asymptote means when x approaches to negative infinity, my corresponding f of x, which is y value, will approach to x-axis. How to represent x-axis? Y equal to 0. So we can say f of x approach to number 0. When x approach to negative infinity, does a tail behave? So f of x approach to 0. Okay, so right now we try to interpret. We notice that how to graph the inverse function must be this one, right? Because we know this must be reflected about y equal to x. So right now we go back to the range. What's the range? So range from 0 to infinity. So this can bring up what's a log function. So log domain will look up range. So what's the C? This is domain, the range. The range is domain. So 0 to infinity. So what's the graph look? The graph looks same. So this time a little different. If we have y-intercept, interchange x and y, so we have x-intercept. 0, 1 become 1, 0. So we have a 1, 0. We have no x-intercept, so we here has no y-intercept. We have a horizontal asymptote, means we have the vertical asymptote. What's a vertical asymptote? Is the y-axis. This time is a null function. We just represent a vertical line, x equal to 0, represent vertical asymptote. So what's a vertical asymptote? Vertical asymptote means when x approach to 0, in this case, from the left. So we have little minus sign represent from the left. X approach to 0 from left. My corresponding f of x will approach to infinity. This case is not a positive infinity, approach to negative infinity. So we see here, we just do the roughly, so this is E. So we use E here. What's E? If it's E, what's a log 1, guys? If x equal to 1, what's the answer? X equal to 1, ln 1 equal to 0. So we have 1, 0. Then all the point we have, what's a point inside? If this is the 1 over 2, so this is 2 point, so it roughly here, we can draw the point like this, okay? So this point, if it's E, 2.71, so equal to 1. Okay? So what's the test point they will give you? Test point is, they want to figure out, so you see these are two graphs, both increasing, will reflect about y equal to x. You want to combine these two, they just reflect about y equal to x. You can figure out the corresponding, the inverse value here. So this is same. This is just the left hand side. This is just the right hand side. They're both same thing. So test point for this case, since I have horizontal asymptote. What's a horizontal asymptote's y value? This means test point will be vertical shift. Test point for exponential is a vertical shift. What's a test point? The test point means like they give you exam, right? What's the starting point? They usually starting from the vertical shift because the vertical shift affect horizontal asymptote. What about logarithm? If they give you a test, okay, how to test you? they usually give you the horizontal shift. Affect vertical asymptote. Okay, so this is only two cases, like this case. Now, right now we go back here. What about this case here? First, this exponential function. So the test point, what's the test they want to give you? They usually roughly to trick you for the vertical shift. Why? Because we want to figure out horizontal asymptote, and a vertical shift affect horizontal asymptote. We use H8 to represent. So this we have e to the x horizontal asymptote y equal to 0. So what about plus 2? Plus 2 means my horizontal asymptote from y equal to 0 become y equal to 2. So this is my horizontal as a new horizontal asymptote. You have to list this in the test. You have to point out this is horizontal asymptote. You have to write on that. This is a horizontal asymptote. Okay, so right now we just graphed it roughly. You can set up a table for e to the x. It's not a big deal. What's e to the x there? You know, even you do not want to draw a table, you have the idea. What's the idea? You know that any exponential function will pass what? See, we forgot about this at the beginning. We know this is the final answer, you have to know. From e to the x, so we'll pass 0, 1. This point just roughly, okay? Just around this shape. You only need to point out 0, 1. That's it. So right now, always move the vertical shift the last step, okay? Because first we do horizontal shift. Step 2, we do horizontal or vertical stretch or shrink. Number 3, we do reflection. Number 4, we're talking about vertical shift. This always go to last step, okay? So then we have this e to the x. What about negative e to the x? We just noticed the previous one, the log base 3 of x. So that's add a negative sign means we reflect about x-axis or reflection. Reflection for x-axis means all the y value change sign. So this is the y value here. So then become negative. And this is here become negative. And this there become negative. We just rewriting them. Okay, what's the point here? The red one point, this time it become y value change sign becomes 0, comma, -1. Because reflection about the x-axis, only y value change sign. X value remain unchanged. So then, even for this red curve, red graph, our horizontal asymptote still y equal to 0. Now, we stop, lost the touch. What's the lost touch? The horizontal asymptote from y equal to 0 go up 2 units. So this is 1 and this is 2. We draw this. So this is 2 units. So it means all the points shift up because you already know. So for the graph, it's here. We draw this. Just anywhere, roughly. This is negative e to the x. Okay, we're already doing the shifting. This represents negative e to the x. Then the point here is 0, -1. So they need you to graph label horizontal asymptote, the new horizontal asymptote. What's the new? This is the old. y equal to 0, which is older one. What's the new one? New one just from this, let's just pretend this x-axis shift up 2 units. So it means all the corresponding shift up 2 units. So the point shift up. So what about 0, still 0? What about -1? The vertical shift affect the y value. What about -1 plus 2 equal to, what about -1 plus 2 equal to 1? Or you can do shift 1, 2. So x value, no change. So we have 0, comma, 1. Rest will be same, okay? So how to figure out the corresponding y value here? So far I have x value. What's the y value? How to solve for y value? How to solve it? Very simple. Just replace x by 0. E to the 1, e to the 0 equal to 1. Negative, drop down, plus 2. So this equal to 1. We have it, 0, comma 1. This is another way you can solve it without doing shifting. Another way, just solve it, okay? You can find it. So we have 0, comma 1. X-intercept, another way, just going shifting. What about x-intercept? Set f of x equal to 0. This is f of x, so means negative e to the x plus 2 equal to 0, means e to the x equal to 2. Take both sides lane, so x equal to lane 2, okay? What about lane 1? Lane 1 is 0. What about lane 2? X around equal to lane 2, so just plug in here. So this will be just around here, so okay? So in the test, you don't know what's a lane 2 means. So you just simply like, even you say, I have no idea what's a lane 2 means, okay? So then you just like roughly lane 2 around like less than 1, around 0.7 something. Even you don't know, you just anywhere. You don't know, right? Doesn't matter. You don't have to know what's a lane 2 equal to. You just label here as lane 2, comma, 0. That's fine. You will earn the full credit. Okay? If you really want to do, like I say, really want to buy scale, if some student like me, I know what's a lane 2 equal to. Lane 2 equal to, if you want to treat this one, lane 2 equal to 0.7 something. So just like you can write on this as well. If you say, Missy, and I don't know what's a lane 2 equal to, so just label the points it has lane 2, comma 0. This all accepted. Okay? But you have to label x-intercept, y-intercept, and horizontal, asymptote. Just write on this next to each other, horizontal, asymptote. That's it. Anything else? What about inverse? Are you okay for the inverse? Inverse? I don't think they will give you the how to find the inverse. That one. What about trig function? The trig? This, I don't think so. What about this? Are you okay for this, the graph? Oh, they don't need your graph, so don't worry about it. So this is the first I have to figure out if they give you like this. So this means I try to figure out f of g of -1. How to read it? F of g of -1. So we always start from the inner function. What's the inner function? We start from this first. The figure, what's my g? So this is g. So write down underneath g. So g of -1. What's a g of -1 means? G of -1 means I let x equal to -1. So it means every time this g function, every time cx are replaced by -1. So rest are just copy. So -1 plus 2. So they have a lane 1. Any base, as long as argument equal to 1, then so equal to 0, because b to the 0 equal to 1. So this equal to 0. So the corresponding point will be -1, comma 0. So we notice that g of -1 is equal to 0. Always start from inner function. Again, always start from inner function. Then I know g of -1 equal to 0, so replace by 0. Then copy everything. So right now become, what about f of 0 equal to? So f of 0, we define as two functions, not just one. G is only one function, but f function, you have two formulas. You have to choose, but you can only choose only one. You cannot choose two. Which one you're supposed to use depends on domain value. So this means when x equal to 0. X equal to 0 means the first formula you can use. But the second formula, there's no equal sign. If you plug in, you have the wrong answer. So f of 0 means when x equal to 0, so you have to use the first one. First one is x minus 1. This means every time cx, replaced by 0. So this will be 0 minus 1 equal to -1. That's the final answer, okay? I want to emphasize a little bit something. What about this one? Are you okay for this one? This one actually will have a bunch of answer though. So this is like, this is okay, right? This is okay. So first, you see exponent as the variable. If exponent has a variable, your first option want to bring the exponent to the front because this is x variable and the exponent side. I want to bring them down. How? Apply log. Before you apply log, you have to notice that if you want to apply b to the x, you want to apply log, you have to apply the same base. This is the same base. But this one's same. You have to apply log 3. But before you apply log 3, you can trim everything. You just leave 3 to the x to the 1 to the one side. How to do that? Step 1, divided by 2 to the both side. So I left 5 plus 3 to the x plus 1 equal to 50. Still not clear. I want to clear everything before 3 to the x plus 1. So we trim again. Subtract the 5 to the one side. So subtract 5. Cancels. Subtract 5. So we have 3 to the x plus 1 equal to 45. You have two we can do. One, we just apply lane. So x plus 1 to the front. So we have x plus 1, lane 3 equal to lane 45. So then x plus 1 equal to lane 45 over lane 3. So of x, subtract 1. So lane 45. Do not try to cancel that. Just leave it. What's this represent? Lane 45, lane 3. I can convert to log 3 base of 45 minus 1. You don't have to convert this. I take this as a full credit, okay? Another way is, I don't suggest this way we usually use, even for calculus, we use this way here. So another way is simply apply starting from here. Option 2. This option 1, most popular use. Option 2 will be this. We're still starting from 3 to the x plus 1 equal to 45. based on the rule, if I want to cancel the 3, I have to compose the log 3 base. So we want to compose a log 3 base. So I have to compose 2 sides. So this guy cancels. So I have x plus 1 to log base 3 of 45. So then we solve for that. These two answers are exact same, just different look. Because if we have ln log base A of B, we can convert to any base as ln B over ln A or log B over log A, they're the same. Okay, so this we can convert back, become log 3 base of 45. They're exactly the same. Both two answers we accept. Okay, you use which way you feel comfortable, just use which way. The both ways work. Okay, so I just want to emphasize for this one here. I don't know, they will give you or don't give you. So what about this is okay, right? This is easy. Okay, this is okay. Simply find this way to solve. Do not find the inverse function. Don't suggest this way. It's longer. Okay, we can always like, because if we have this is f inverse of y equal to x here. So we can like apply f to the both sides. So this cancels y equal to f of x. Okay, so means you can replace 2, replace f of x. Another way, just represent which x value, return y value equal to 2. So just simply let y value equal to 2 to solve it. This is easier than this. This is just a theory behind. Just simply let this 2 replace f of x, then try to solve x. This is the easier way. Don't suggest find the inverse function, plug into. That's too hard, okay? So we have, let's see what else I need to emphasize. Okay, we're talking about inverse trick. We have, I want to redo one more time. We have for the inverse trick, for the sine, cosine, and tangent, we have 0, pi over 2, negative pi over 2. We don't use 3 pi over 2. We use negative pi over 2. And this is a pi. We don't use this part. No quadrant 3. We only use quadrant 1, quadrant 2, and a quadrant 4. Except this one. Except this. Okay, do not try to figure out. This cannot be the answer there. We just make a summary notes for sine inverse, a positive value there, a cosine inverse, a positive value. Sine, by the way, I don't mention that sine inverse, cosine inverse, you can use arctangent to represent. Why? When you take calculus, you'll find it very surprising why teacher, instead of use sine inverse, they try to use arcsine or arctangent. Because a lot of students confuse. When you think about sine inverse, this is inverse, right? They always read it as -1. They always confuse as a negative power. That's why usually in a calculus 1 or calculus 2, teacher, instead of use sine inverse or -1, sine inverse, this read a sine inverse, not sine negative power -1. They don't read it, the sine inverse. In that of a student confused about the negative power, they use this way to represent. Just remember, arcsine, arctangent, arccosine, all represent arccosine, cosine inverse, arctangent, tangent inverse, arcsine, sine inverse. They are same. Okay, just remember they are same. So right now we go back here, sine inverse of positive value and tangent inverse, positive value. So this is equal to the reference angle. For example, we have sine inverse of 1/2, cosine inverse radical 2/2, tangent inverse of radical 3. Since they are positive, we know we only have 3 reference angles can refer to: 30 degree, pi/6, 45 degree, pi/4, and 60 degree, pi/3. We notice that we have a little chart. One more time. I hope you remember. So this is a data. So sine, this is not talking about inverse, it's just sine data. We have, sorry, I'll write on data sine the other side. We have pi/6. We have pi/4. We have pi/3. Sine, cosine, and a tangent. We start from 1/2, then radical 2/2, then radical 3/2. And they are cofunction, so reverse it. And this just take a quotient. What's the quotient? 1/2 over radical 3/2 equal to 1 over radical 3. Rationalize, become radical 3/3. These are two same, equal to 1, and this equal to radical 3. So now we go back there. What about sine inverse of 1/2? So this means which data returns y value equal to 1/2. So what's the value here? We notice that sine pi/6 returns value equal to 1/2. So this equal to pi/6. This is easy. Pi/4. What about radical 3? Pi/3. Positive value, easy to figure out. But what about negative value? When we talk about negative value for inverse, a sine and tangent will be easy to figure out, but not cosine. Sine inverse of negative value, tangent inverse of negative value, just equal to reference angle, but this time this reference angle, you should add negative sign. So say, for example, I have sine inverse of -1/2. We notice that sine inverse of positive 1/2 equal to pi/6. So we simply add negative sign before pi/6 equal to negative pi/6. Still easy. First, to figure out what's a positive angle, what's a positive number here. The reference angle is a 1, 2, 3. So then add a negative sign. So what about cosine inverse? Now let's hold it. Cosine inverse is a little different. So I have tangent inverse. This time we give another easy value. Give -1 there. We know tangent inverse positive 1 equal to 45 degree equal to pi/4. So this is the same reference angle pi/4. You just simply add negative sign. So that's it. Okay, so this is also okay. But what about cosine inverse of negative value here? You cannot use this rule. This rule only for sine tangent. Then this time have a negative value here. Also easy, since this is second quadrant, reference angle will be here. So the data should be pi minus reference angle. Only this a little different, okay? If they give you positive, all positive here, don't think too much. It just equal to reference angle. If they only happen in a cosine inverse a negative value, you will have to use this formula. So say I have cosine inverse of -1/2. So what's the cosine positive inverse positive 1/2? So this is cosine positive 1/2 equal to pi/3. So this first we figure out reference angle pi/3. First, just figure out which value returns positive 1/2, so which is pi/3. So then the formula is pi minus pi/3. What's a pi minus pi/3? This 3 pi/3 minus 1 pi/3 equal to 2 pi/3. Then what about cosine inverse of negative radical 2/2? So this will equal to, first, which value cosine inverse positive value radical 2/2, which returns pi/4. Since it's negative value, we have to use pi minus reference angle. 4 pi/4 minus 1 pi/4 equal to 3 pi/4. Then what about cosine inverse of negative radical 3/2? What's a negative radical 3/2? So this equal to, which value give you a positive radical 3/2, which is pi/6. So the formula is pi minus pi/6. 6 pi/6 minus 1 pi/6, 5 pi/6. Only this, just go over that. I hope tomorrow they will still give you a positive, then don't worry about it, okay? If they give you negative or the sine tangent, just add a negative sign before reference angle, but a cosine you have to do extra step. Just simply, but sometimes they will give you this, they say, what about, this is a long time ago, department final. Sine inverse of -1/2 minus cosine inverse -1/2. They have this, okay? So then this equal to sine inverse of -1/2, just simply equal to, what about first just figure out what's a 1/2, the reference angle, pi/6. Sine the tangent, negative sign, just add negative sign before the reference angle, you're done. But this part, since have two term, you better leave inside of parentheses, okay? We notice that cosine inverse of -1/2 equal to pi minus pi/3. So just write it, unless you find out inside is 2 pi/3. So then this equal to negative pi/6 minus 2 pi/3. You want to make same LCD. Make a 6. So top times 2, bottom times 2. So I have same LCD, same sign, means add two numbers. Collect the numerator, pi plus 4 pi equal to 5 pi. Common sign, negative. If they give you this, just should know how to do it. I highly doubt it, okay? I still think they will give you a positive value here because this is a little tricky for the cosine inverse. So sine tangent inverse easy, just a negative sign before that, okay? Only this is a little harder. Just follow this way, okay? This I want to give you extra. I don't think you have a problem for this one. So this is like a multiplicity. This should be roughly sketch, will be easy. First to figure out what's the end behavior for the graph. So what's end behavior? Depends on highest degree. So we have a sub n, x to the n power. So degree is 3, which is odd. If it's odd number, means either different direction though. That's odd number means. Different direction depends on leading coefficient. If leading coefficient less than 0, rise on the left, fall to the right. If leading coefficient larger than 0, rise on the right, fall to the left. So this leading coefficient is 1, which are larger than 0, so must be this shape. Step 1. Now you have to pull out the common factor. How to pull out? Pick the lowest power. Let's say you have x, and x. Pick the x variable with the lowest power, which is 1. That's the lowest. So pull out x. Then this becomes x minus 3, x plus 1. So notice that the multiplicity power is 1, 1, 1. 1 is our number, so we'll cross x-axis. Then, anywhere, you don't have to be accurate. First, just label x-intercept. So we have 0, and we have 3, and we have -1. This any behavior, all cross, so just cross. This is what cross means. So then, any behavior, anywhere, this is any behavior, this way. So in between, I have to pass how many zeros? Oh, I don't have to cross here, sorry. This is nothing, this is not intercept, okay? I only have 0, 3, -1s. You have to cross this one. So means this any behavior, I have to connect my second 0, but I have to cross it. Just cross it, okay? Then connect my last 0. That's it. You can any shape, as long as matching this will be good. Okay, that's it. So if they give you like, they usually with test point will be this. They say, what about x cubed x squared minus 9? What about this? Every time see this, you see here. Say I give you this one. I have g of x equal to x squared times x squared minus 9. Even worse, to give a negative sign outside. Okay, so then this is x squared, you're done. What about x squared minus 9 is equal to x plus 3, x minus 3. This you should know, okay? So we have like a right now add a power, 2 plus 2 equal to 4. X squared times x to the third, x third times x will be x to the fourth. So right now we have this and a behavior test. This time it's even. If it's even number means same direction. Either both goes up or both goes down. That's even means. If odd, different direction. Both goes up if leading coefficient larger than 0, both goes up. If leading coefficient less than 0, both go down. Okay? So this is, what about this? This is both go down because leading coefficient is less than 0, which is -1. So it's both goes down. First, figure out. This is, they may give you, because this has happened like a couple years exam. So what about this? We have 0, we have -3, and we have +3, right? So right now we're talking about multiplicity. So it looks like I have 3, I have like degree 4, I may have 3 turns, at the most 4 minus 1 turns. If this number, the power, is even number, means I will not cross x-axis. What about x plus 3? The power is 1. It's our number, means I will cross it. This case is both goes down because of negative sign. I want to pick my second 0. Since I'm not able to cross it, I have to go back. Connect them allow 0. Just give a little curvy. Do not give a corner. because a parabola, it's continuous everywhere. Okay, so this, you have to know this, okay, multiplicity. Its multiplicity is even number, our touch and turns. What else I should... This is okay, right? This problem's okay, right? Sine, cosine, cosine, sine. Or you can simply like solve what's a pi over 3 plus pi over 6. I don't think they will give you such an easy one tomorrow here. It's okay. They maybe just want you to expand it. So this case, happily, you can start from inside first. That's even easier though. You can start
So
first,
to
become
determine
pi
the
over 2.
stand, is my degree
What's a sine
f
pi
can
over
look like
2
this?
equal to 1. Or you can just
Down.
expand it. We
So
have a
is
same
f of
answer.
x, my y-axis going to, so it goes towards.
Again, they have like, they give you like a data of an arc length when r equal to 10, data equal to 30. Just make sure this data has to be the radian mode. How to figure out radian mode is a multiply pi over 180 or multiply 180 over pi. Radian mode, pi must be numerator. So you have to multiply by pi over 180. So that's why multiply by pi over 180. First convert. So this one, 30, convert to radian mode, multiply pi over 180. 30 goes to 180 6 times, so pi over 6. So the radian mode is our data 10 times pi over 6 equal to 5 pi over 6. This high chance will be in the exam every year, okay? This is okay, right? This is fine, right? This one. Okay, so my students should have no problem with this. You don't have to generalize the equation, only because they only give you 0 to 2 pi, okay? 0 to 2 pi. This one, I still suggest doing this way here, okay? Sometimes they make it complicated, just make it easy. Because if you draw the regular triangle, okay, you can draw any triangle to figure out. But the problem, what about sine? Sine may be an issue there. So I would suggest you, especially when you're starting level, when entry level here, do not make mistake. If they already tell you the quadrant 3, just apply this triangle in quadrant 3, then automatically tell you the sine. So this is quadrant 3, both x and y value are negative. So this means tangent opposite of adjacent, so -3, -4, they're very easily to figure out the rest of them. So sine 2 data, just memorize it, equal to 2 sine data, cosine data. You have to memorize it, no choice, okay? So then simplify, just pull out. You can pull out, you can starting from here, it doesn't matter. This is not a big issue. You can do 2 sine data, cosine data. What's a sine data equal to? Sine data opposite over hypotenuse. Remember, hypotenuse always positive. If you want to talking about the negative value, only x value y value can be negative, not hypotenuse, okay? So you can do this way here. So cosine will be adjacent over hypotenuse, -4 over 5. So 2 times sine data opposite over adjacent over hypotenuse, -3 over 5 plus 1. Figure out the final answer here. Okay, by the way, tomorrow we have a science sheet. We have, let's see, because department already gave the sheet, you know, what's the seating. I don't know where they put the seating. They sent me the seating. So tomorrow, just go there to find a seating. You have the seating number. Okay, there you have a seating number. Because they will have almost 300 students in a class. So I don't know where put a seating. We have a seating assigned tomorrow. Okay, so just tomorrow, just go to like it's a Marshall 3. It's a Marshall 3. Find your on the wall, right? Find your seating. Okay, find your seating first. They give you seating, then go to the design seating. Do not give it because Matthew Palmer already assigned a seat. Just let you know, that's just extra. They sent me, I can't find it. Okay, so tomorrow they will place on the wall. This one has no problem, right? Nothing, right? We did a lot in the test, but looks like this must be the final. Any question for this? Or if you don't think you need to explain, so I go to next one. Just every time find an answer here, just make sure to back substitute, okay? Back substitute. Find the corresponding x value. Ellipse, see here is again one more time, ellipse. If you want to first grouping x and x, grouping y and y. So just like let the number go to other side, constant. So then how to do that? So just how to completing square, always add, take a half of linear coefficient divided by 2, square the both sides, left and right. Just the same. This, you have to do something. Okay, what's you have to do? I know some students prefer this way, some students prefer another way. Let's do one more time. Let's try one more time for this. So let's copy this one. We don't have. Okay, let's try one more time because it looks like this must be in a test. So first we just grouping x with x. Leave space and a y with y. The constant, just to make the other side. Positive become negative. Then we try to pull out the common factor 4. 4 pull out mean divided. 4y squared over 4, y squared. Negative ay over 4, negative 2y. That's it. So right hand side is 2, negative 4. So right now we try to completing how to always add, take a half. This half means linear coefficient, which is a 4, left and a right. So we try same, take a linear coefficient. What's a linear coefficient? Linear coefficient is take a half of linear coefficient, this time is a negative. Okay. So the previous way we try to introduce just add something, subtract. Another way just we want to add the two sides. But this time add the two sides, not just this, we have to multiply by 4. So we simply add 4 times this guy, okay, because this we don't have. So this is 4 times, okay, so we're done. So right now, left hand side, we're almost finished, equal to x. What's inside the parentheses? Positive 2 plus 4. Y, what's inside the parentheses? Negative 1. Right hand side, you will have to solve it. So this is negative 4. 4 over 2 is 2. 2 squares 4. Plus 4 times negative 2 over 2 is negative 1. Negative 1 quantity square equal to positive 1. So this 2 cancels. So we have final x plus 2. This is a much shorter. This way is books usually suggest if they add something inside parentheses, you have to subtract at the same time. If it's the equation, I would suggest this way, okay? Add 2 sides, but you have to make sure multiply by 4. So right now we should divide it by 4 each side. But then this becomes we have nothing in the bottom here. Okay. So I have A always larger than B. So A here equal to 2, B equal to 1. It's a horizontal or vertical. The vertical horizontal depends on what? Which bigger number, larger number, which number large? 2 is larger than 1. And this 2 is under X. So it will be major X-axis, means it's horizontal. Okay? If it's like 2 is under Y, 2 is under Y, means this will be major. What's a major? The long. This long length will be long. So this will be vertical. In this case, it will be horizontal. Why horizontal? Because 2 is larger than 1, and AO is larger than 1, and 2 is under X. So this is a horizontal ellipse. That's it. Okay, so we have horizontal. So first I have to figure out the center point. What's a center point? Center point will be, what's a center? Center is -2, comma 1. So we have -2, comma 1. This is center points, okay. What's ellipse? What's ellipse? Ellipse is A equal to 2. That's a major x-axis, horizontal ellipse, right? They're just like, let me write on this. Okay. You don't need that fancy, okay, for that. Sometimes I make it as a little, I just want to look perfect. Doesn't mean you need it. So this is center points. You can label the center points. Say -2, comma 1. Just label them. This is a major x-axis. Why major axis? Because 4, because what? 2 is under X. 2 is under X means x-axis, the horizontal, which should be longer. So go to 2 place to the right. Here's another color. Starting here, 2 place to the right, 2 place to the left. You can label the points, very easy to label. The y value always 1. So -2 plus -2 plus 2 equal to what? 0. What about -2 minus 2? -4, comma 1. We simply count by hand. What about corresponding y value or corresponding b? B is a vertical. This is a major x-axis. So it'll be minor axis will be shorter version. This is shorter. So there will be a flat one. Okay, then label some points there. Endpoints. What's endpoints here? Will be -2, comma 0. Just label some points. The corresponding y value add a 1. So this will be -2, comma -2, comma 2. This is -2, comma 1 will be -2, comma 2, the green part. Just like this. Okay. So I see you're very ready now. This is okay, right? This one, I think all my students will be expert for doing this type of stuff. Still remember half-life doubling? If they do give you half-life or doubling, just make sure half-life or doubling. Then,
I had a question.
yes,
In paper, like sample B, question 2.
sample, okay, let me go back there. Okay, give me a second.
Mhm.
This is A, so this is B. So which question there?
Question 2.
Question 2. Yes, for this one. Yes. Yes.
Can you explain this question one more time? Because I was doing it by myself and I didn't quite understand it very well.
Okay. So first we draw a pole. It should be vertical, right? Let's. This is okay? This is okay, right? So this stake is to be driven into the ground away from the base. What's away from the base means? Let's see here. Let's see here. You can go this way, you can go that way, it doesn't matter. Which way you want? You want this way to the left? This one drove into the ground away from the base. This is a base, right? This is a base. So we say draw a horizontal. This is a base. What's a base? This is a 15 feet to 15 foot pole. So this is a 50 feet. Okay, so a Y from on the ground to the top of the pole. This is a top. This is a base. Yes or no? This part is okay, right? Top is okay, right? Base and a top. So Y wiring them. Okay? This okay?
Yes.
Okay. So this is like elevation. What's elevation? Elevation is from the horizontal. You look to the sun level. So you're from here. That's your eye level. You look, see this is sun. Okay? That means elevation level here. This elevation of 60 degree. Sometimes we talk about depression. What's a depression means? If the person standing here on the top of the building, so this is cannot be a pole, have a building. So this is look something on the ground. So this is depression. Depression and this angle are same angle. You okay? So right now, make it easy, just talking about elevation. So we have a 60 degree here. So I want to find, so far we only have, this is 60 degree and the height of the pole. We only have this information, 1 and 2. So I want to find at what distance from the base of pole should the stick be placed. So I need to find here. Need to find the distance here. Okay, so say this is unknown. Let's say this is X value there. So now you have only 3 triangle can use. You can sine, tangent, sine, cosine, and a tangent can use. But you don't know which one you're supposed to use. But you can write on this. Circator, HHA. Every time write on this, on the paper. Then, in terms of 60 degree, this height is opposite. So we have a degree, we have opposite. This, what about this? This is adjacent. So we have opposite of adjacent means that's the only option we can use. Which only option we can use? Opposite and adjacent is tangent. So I have to narrow down. That's a tangent I'm supposed to use. So we can say tangent 60 is equal to opposite over adjacent. Right now, just follow this. Okay, opposite of adjacent. So then find out what's the x here. So cross multiply x times tangent 60 equal to 50. How to solve x? So x equal to 50 over tangent 60. What's a tangent 60 equal to radical 3? You don't have to rationalize, just give you this answer there. That's fine. Okay? Are you okay? If it's still confused, I can explain more. So if it's okay, so right now we need to figure out what will be the length of the while. This is the while. What's the length of wire from the stake to the top of the pole? So this time you look up this again one more time. So this is, you always look up, you always use the given information. What's a given? 50, 60 given. Do not try to use this X information. Maybe this is the wrong answer you figure out. Okay, always try to stay with the given information. This answer is correct, but maybe you find the wrong answer. So try to avoid use X value here. So what's a given value? 50 and 60, that's a given. In terms of this hypotenuse, so we have opposite over hypotenuse. What's opposite over hypotenuse? Equal to sine. So this will be sine. So rewrite it like sine 60 is equal to opposite over, let's say this is y. Opposite over hypotenuse. So what's the sine 60? Equal to radical 3 over 2 equal to 50 over y. We figure out y here. What's the y? Cross multiply. So we have radical 3 times y equal to 2 times 50 is 100. How to solve y? Both sides divided by radical 3. So 100 divided by radical 3 will be the final answer. This okay? It's still not okay. I can explain one more time.
I understand it now. Thank you.
Okay. Anything else?
Yes. Can you explain question 10?
Same paper. Give me
Yes.
a second. I need to charge more battery. Okay, which one? Question number?
Question 10?
Question 10. Okay, let me go to the question 10 here. Oh, I did a lot of this paper. This one? This one? Okay.
Yes.
Okay, so think about this call. Oh, let me read it one more time. Okay, you think about this. Why they write? Why they just like express the expression? So this is expression. Why expression? Because we don't have equal sign, so we cannot call the equation. It's not equation, must be expression. Express the expression of this in terms of sine or cosine. You want to like simplify this in terms of sine cosine. Why? When you try to prove identity or try to prove something, always go to reduced form. What's a reduced form? Sine and a cosine are reduced form. So it means if you have tangent, you have to convert it, okay? So right now we have some that cofunction. Every time mention 90 minus degree, we know the cofunction. Remember why? I say you can reverse it. That little chart, y sine 30 equal to cosine 60. Tangent 30 equal to cotangent what? Cotangent 60. Okay, so all this called a cofunction there. So what's a cofunction? Another way, I don't know which way I proved it the last time, but did I use a cofunction there? Yeah, I use a cofunction. Okay, let's use a cofunction. Cofunction will be easier though. So why this equal to? Why sine 30 equal to cosine 60? This, back to a long time ago, we're teaching. So we're talking about cofunction. Cofunction is if two angle adds up, what's a 30 plus 60 equal to 90 degree? They form a co-complement relation. Okay, two angle adds up, it's 90 degree. 30 plus 60 is a 90 degree. So this means, so then they develop a formula. What's a formula? If sine data equal to cofunction will be cosine. Is 90 minus that data. So just implement sine 30. Data replaced by 30. So this equal to cosine 90 minus 30, which give you cosine 60. Okay? So this is same. So we have right now, we're not talking about this. Now I tell you, a sine is cosine. Cosine is sine. Tangent is cotangent. So what about this? If a tangent data equal to cotangent 90 minus data. Vice versa, we have cotangent data is equal to tangent 90 minus data. Remember, this data add a 90 minus data will cancels out, still equal to 90. So right now we want to adopt the formula. Tangent 90 minus A is equal to cotangent A. Bottom leave unchanged. Cosine A, sine A. By quotient identity, cotangent equal to cosine over sine. Why? Because tangent equal to sine over cosine. So cotangent equal to cosine A over sine A over cosine A, sine A. So that's okay? I try to move to somewhere. So far it's okay. So because I'm telling you, a problem can use different way to solve, not just a one way, okay? So then we have to do something. What do we try to do? We try to do something. So it's just like, don't like sine data, sine A. I want to cancel that. So top and bottom minus times this. So this guy cancels. So left with cosine A over cosine A, sine A times sine A, sine A squared. The cosine cancel equal to 1 over sine square A. What's the reciprocal of sine? You can just simply like this, okay? It doesn't matter. I don't know what's the last time I did. Yeah, I just like doing this. Then simplify expression. Yeah, you can maybe give the final answer like cosecant square A. That's it. Or you just leave it like 1 over sine square A. If you still want to prove the identity, what's the reciprocal identity will be? Reciprocal identity 1 over sine square just equal to cosecant square. You just leave this, they give you full credit. Okay. Anything else?
Can we go over number 14 for sample B?
Yeah. Give me a second, okay? This both will accept this or this, okay? Oh no, not negative, equal to 14. Let's go to 14. This one?
Yes.
Okay. So when we're talking about the log function, the definition of the logarithm. What's the definition of logarithm is? We have log base b of x equal to 1. If and only if this is called the log form, we have a corresponding exponential form. Base, always base. Raised power to 1. Sorry, this is a y, not a 1. Raised power to y, go back, equal to this part called the argument. This is a definition of logarithm. So right now I want to apply this definition of logarithm, and this is a base. This is a log form. We have a corresponding the exponential form, have to raise them. So base, it's x plus 3 as 1 unit, raised power to 2, equal to everything. We simplify this. This is a perfect square trinomial. We yield 3 terms. So first term square plus 2ab, 2 times 3 is 6x plus 9 equal to right hand side x cubed plus x minus 2 over x. Since this is equal sign, you can cross multiply. If it is a larger equal to, you are now allowed to cross multiply. This equal sign, you can cross multiply. So we have x times x squared plus 6x plus 9 equal to x cubed plus x minus 2. So we just distribute x times x squared will be same level add a power, same level 6x squared plus 9x equal to x cubed plus x minus 2. If a two sides term, usually you have a two sides, you can cancel them. Why you cancel? If a two terms, two have the same sign, you can cancel them. It's the same as subtract x cubed to the both sides. They will both are canceled. Even right now you have 6x squared plus 9x. Right hand side you have x minus 2. If you see x squared and x at the same time, you better leave one side equal to 0. So how to do that? Cross out, go to the left hand side, become minus x. Cross out, become plus 2 to the both side, add 2. This side equal to 0. Left hand side, 6x squared plus 8x plus 2 equal to 0. Easy way, if you see this equation, then divide it by 2 each side. How to do that? You can use Chinese way. Plus sign means find a sum. Or you can use AC way. I try to go over AC way if you're not comfortable for this way. So equal to x equal to negative 1 over 3. Same sign, answer must be negative. Don't bother to check because they say do not check it for extraneous solution. You don't have to plug in. Another way to find AC is 3x squared plus 4x plus 1 equal to 0. How to solve for 0? You have to convert to a factor form. Plus 1. What's AC? AC is A times C, which is 3. Positive 3. AC, first term, Last term remain unchanged. Two terms. We can break down. Plus sign means finding sum. Either both positive, both negative, depends on middle sign. Middle is positive, both positive. So rewrite it. GCF, 3x. 3x over 3x, x. 3x over 3x, 1. Nothing common. Sign drop down. 1 always common. Pull out a common factor. Becomes 3x plus 1 equal to 0. First factor equal to 0, negative 1. Second factor equal to 0, negative 1/3. Okay, that's it. Anything else?
Professor,
Yes,
can we go over doubling and half-life, please?
doubling half-life. We don't have specific the question here. Okay, just remember when talking about doubling, half-life, okay, so I have very simple answers here. So just like right now, let's say doubling this time. Let's say I want to, okay, the interest rate, I want to invest my money in, put my money in the market. Okay, so I have $20,000. I want to, in a bank, earning compound continuously interest rate. Must be compound continuous. Compound continuous means we use exponential. Okay, so compound continuously as the interest rate 8%. That's impossible, by the way. So then how long will double? Okay, this is one of the question there. So how long we double? So we notice that how long we double. So we have what's exponential increasing? Initial is 20,000. Exponential compound continuously, we use E to the, I remember one problem is like interest rate is some 8%, right? So then this will be 0.08 times this, or this already know the R. Let's see how long. Okay, so we have this. In this problem here, if we know this is interest rate, and we have the answer right away. We not even need to set up this. How long we double? If we mention double in a half-life, then R times T must equal to ln 2. Interest rate 0.08. How long we double? We know the answer right away. We don't have to set up anything. Just like ln 2 divided by R, which is ln 2 divided by 0.08. Okay, that's it. Half-life same, like radioactive decay. Do they have a half-life? I think like, but whatever. As long as they mention half-life and doubling, this relation must be true. This is growth rate. This is a time, R times T must equal to ln 2. You can always use the relationship, play around. Anything else? Oh, tomorrow again, I want to, one more time. So tomorrow, they will assign a seat. Okay, when you enter the Marshall 3, we are no longer in the Marshall 4, use the Marshall 3. So first, outside the wall, you will see your assignment. Your like a seat assignment. It will send you assignment. So tomorrow I go there to look, your seat assignment will be there, okay? So just like make sure, look over your seat before you enter the room. I think they give me the seat like A, B, C, D, E, F, G. So that's we count like 2 even number. 2, 4, 6, like 8, 10, or 12. We use like I see that's the column number. The row number is A, B, C, D, E, F, G. Okay, the column number is 0 to like 0, 1, 2, 3, 4, 5. We use even number like a 2, 4, 6, 8. That's Master Palm assignment. It just you guys just need to make sure to read the seat number before enter the Marshall 3. Okay. The rest will be same. David John and we have 2 men, like one me. I also the proctor exam tomorrow. Okay, so make sure to enter the classroom early because they will not allow you to enter. If like I don't know how long the window time, maybe 20 minutes or 30 minutes, then no student will allow enter. So you just make sure to enter classroom on time. I don't know what about tomorrow's weather. It's raining or not raining. So anything else?
Can we go over number 9?
Tomorrow, unfortunately, I'm sorry, just give me a second. Tomorrow we have, tomorrow 100% raining, okay. And the plus will be very cold, 54, 48 to 50. Wow, so cold. 48. Wow. Sorry, guys. You still have to go too, okay? Just let you know. Okay, I'm sorry. Which number?
Number 9.
Same paper?
Yes.
Number 9. This one?
Yeah.
Okay. Oh, this I wrote answer last time. So this is first, just like you have to know what's assigned to data equal to. Always remember 2 formulas by heart. Which 2 formulas? They only test you 2 formulas. First formula, which easy version, sine 2. They can be 2x, 2 data equal to 2 sine x cosine x. So this can be 2 sine data, cosine data. If they give you cosine 2x, they equal to cosine square of x minus sine square x equal to 2 cosine square x minus 1 and equal to 1 minus 2 sine square x. You have to play around this formula for this cosine 2x and sine 2x, okay? So once you solve for one side, you are now allowed to cancel. You cannot like both sides divided by sine data to cancel that because you don't know what the sine data add up to. If this is 0, you cannot divide it by 0. You can't. So just leave it. You simply move to one side, set up another side equal to 0. What's a GCF? When you try to do the factor form, always figure out what is the GCF. So it looks like GCF is sine data. Pull out the sine data, left 2 cosine data, minus 1 equal to 0. First factor equal to 0, data equal to n pi. This is the generalized formula. So n0, so n equal to 0 will be 0, 1 will be pi, 2 is 2 pi. Cosine data equal to 1 over 2. This is a cosine function. 1 over 2 in the middle, you will see 2 answers. Cosine data equal to 1 over 2. First, the reference angle give you, what's the reference angle for cosine positive 1 over 2? Which is pi over what? Pi over what?
3.
Yes, pi over 3, which is 60 degree. Why pi over 3? Pi over 3 is 60 degree. What's a cofunction? Sine 30 degree. 30 plus 60 is 90 degree. Okay, so sine 30 equal to cosine 60. So cosine 60 degree, which is pi over 6, pi over 3. Then this is the first quadrant. What about last quadrant? Last quadrant, just what's the last quadrant means? That this is reference angle pi over 3. Reference angle. What's my data actually? Data will be here. Okay, the red one data equal to big rotation. The whole rotation will be 2 pi minus pi over 3. What's a 2 pi minus pi over 3? 6 pi over 3 minus 1 pi over 3, 5 pi over 3. Okay, that's just from 5 pi over 3 from. It's okay. Here are two answers, pi over 3. Because they didn't ask you, the easy version they give you from 0 to 2 pi. So you can use generalized equation, but only have two options there. Anything else? Are you okay? Not okay? I try to explain in another way.
I'm still a bit confused about that one.
No, which part confused? I try to use different way to explain.
I'm not really sure about, where it says theta is equal to n pi. Can you explain
Oh,
the concept a bit?
This, you have to memorize it. So let's say you would take calculus 2 or calculus 1, 201.
205.
Oh, 205, you don't have to memorize it. If you take 201, right? So just like if you have noticed that only two formula, remember. If sine data equal to 0, you have to figure out what's the data equal to. So data equal to n pi. This is called generalized equation for everything from negative infinity to positive infinity. When the cosine data equal to 0, there's only two things you need to remember. That's just for this test purpose, okay? If sine data equal to 0, data equal to n pi, just remember that. What about cosine data equal to 0? Then data equal to odd. This is our number. What's our number means? Odd multiple of pi over 2. Okay. Odd multiple, this odd number, how to represent our number? What's our number? 3, 5, 7. How to represent our number? I just like use 2 and 2 times any number will be even. Even plus 1 will be odd. So this is pi. This two formula you will have to remember for whatever case. Just remember this 1 and a 2. If sine data equal to 0, data equal to n pi. If cosine data equal to 0, data equal to odd multiple pi over 2. Why you have to memorize it? Because you can solve this question there. So n call, what's n call? Call integer. Any integer. If n equal to 0, 0 times pi will be 0. If n equal to 1, 1 times pi will be pi. N equal to 2, 2 times pi will be 2 pi. In this case, make it easier. You don't have to have a generalized equation because they give you restrict domain from 0 to 2 pi. What if I want to do infinity? That's infinity here. A sine function is continuous forever. Sine function there. The sine function, right? So this is like forever. This is like from negative infinity to positive infinity. That's a domain. What's a sine data equal to 0 means? Means I will have to find x-intercept. This is x-intercept. Okay, so that's what I see here. This is 0 and this is pi. What's the next? 2 pi. What's the next? 3 pi. 4 pi. Same thing here. 0, negative pi, negative 2 pi. Just like this. That's what I need to call generalized equation here for here. N is any integer, any number here. This you will have to memorize it. Or you will very hard to solve it. Very hard to solve it. Okay. If it's really, you said, can't memorize it, but you still have to memorize this graph from 0 to 2 pi, okay? Because that's what they need, 0 to pi. So let's say the sine curve start from 0, maximum, 0, minimum, 0, from 0 to 2 pi. You just see this. Okay. What about sine theta equal to 0? What's equal to 0 means? Means the y value will be 0. The y value here will be 0. This is my x-intercept. You just see 2, 3 intersection 0, pi, and 2 pi will return 0. If this way help you remember, just remember this way, okay? Since you don't need a 201 in future, you can read this as well. If this can help you. You just read, if they give you sine theta equal to 0 means I try to find x-intercept. So this is x-intercept, which is 0, pi, and 2 pi. That's all, right? So this one a little different, just a cosine theta here, just the first graph it, cosine theta. This is 1/2, so you see you have two intersection there. The first to figure out what's the reference angle. First quadrant, the last quadrant, quadrant 4, cosine will be positive. So this is quadrant 4. And next one will be quadrant 1. That's it. If you think this is harder, then try to remember this way, okay? Now I'm asking you, so what about cosine theta? If you do not want to remember this formula there, what about cosine theta equal to 0? What's a cosine curve? That's a cosine curve. Okay, from 0 to 2 pi. So when cosine will be 0 here, you see here first, pi over 2. This is a pi, and this is 3 pi over 2. That's what we call odd multiple of pi over 2. When n equal to 0, pi over 2. When equal to 1, 3 pi over 2. So this is another way use graphing can figure out the answer here. Without notice these formulas. Okay, just remember by graph. This is another way can help. Anything else? Well, almost 9 o'clock. Anything else? No? Then no, it's a no. Let's wrap off. I wrap up. I just hope good luck. God bless you. Good luck to you guys. And just make sure to arrive the classroom before 8 o'clock. Okay, if you can be there 7:30, so 7:40, you can. I think would be better though. Okay, you can prepare, make you comfortable. So then pray. So everything will be fine. It's not big deal. You have but I do find they have a score. I just see your score. The students say the score they posted. I just see the tutoring score really affect big deal to your final points, final grade. I see some student from 90% to 99 percentiles because tutoring, they don't need the tutoring. I feel bad for them. They don't need it, but their score dropped to 89. Okay, so I just feel very bad for this kind of student. So then just let's final can tell. Final take a big percentage. Okay. So just if you do well in the final, that will be okay. Okay, that will be okay. Okay, guys, see you tomorrow. So wish you good luck. All the best to my student. Okay,
Thank you.
Thank you.
welcome. Bye-bye, guys. See you tomorrow. Okay.
Bye.